Relative to the acute angle theta, the three sides of a right triangle are the opposite side, adjacent side, and hypotenuse. In a right triangle, your hypotenuse will always be the longest of the three sides. Depending on where you mark your acute angle theta, if you have to go across the triangle, then the length of this side is considered the opposite side. Adjacent will be the side directly next or attached to your angle. These three sides are mathematically connected by the Pythagorean theorem. The Pythagorean theorem gives us a relationship of the three sides of a right triangle. The two shorter sides are called legs. Those stay together in the equation. The hypotenuse is the longest side, and that will be the variable or the side that gets kept alone when you set up the equation. So leg squared plus leg squared equals hypotenuse squared. The ratio definitions of the 6 trigonometric functions are all based on 2 of the 3 sides above. There's an acronym that you can use to help remember what trig function and which 2 sides go together, and that is called Sohcahtoa. I've heard many catchphrases over the years, some of them a little bit more risque than others. The one that I typically use to remember is some old horse caught another horse taking oats away. And SOH, that group of 3, the SO part of the acronym is sine equals opposite length over hypotenuse length. The Ka is cosine, and that's the adjacent length over the hypotenuse length. And TOA is for tangent. Tangent is opposite over adjacent. Let's put some of this into practice. Find the exact values of the sine, cosine, and tangent trigonometric functions in the figure. Over to the right, we have legs of length 8 and 6. Remember, legs are the ones that form the 90-degree angle. The hypotenuse we can figure out because if you know 2 of the 3 sides, you can use Pythagorean theorem to find the third. Our hypotenuse squared is equal to 6 squared plus 8 squared. So if we add up 36 and 64, we get 100. The square root of 100 is our hypotenuse length of 10. And so that's where this 10 comes from. A squared plus B squared equals C squared. Once you know all 3 triangle side lengths, then using Sohcahtoa, you can write the ratios. Theta is marked in the lower left vertex of this triangle. Sine is from SOA, so that's sine equals opposite over hypotenuse, that's 8 over 10. That reduces to a ratio of 4/5, or just reduce your fraction, basically. Cosine, Ka, is adjacent over hypotenuse, 6 over 10, and that reduces to 3/5. Tangent is TOA, opposite over adjacent, 8 over 6, that's equal to 4/3. Another example, we have a triangle where both legs are 3. Theta again is marked in the lower left vertex. The sides that form the 90-degree angle are 3 and 3. Those are considered legs. We don't know the hypotenuse, but we know how to find it. 3 squared plus 3 squared has to equal the hypotenuse squared. 9 plus 9 is 18. So hypotenuse squared equals 18 means that hypotenuse is the square root of 18. Since 18 has a perfect square factor, we could rewrite 18 using 9 times 2. Square root of 9 is 3. Square root of 2 is irrational, so we leave it under a radical. Using our Sohcahtoa acronym, we can build sine. Sine is opposite over hypotenuse, 3 over 3 square root of 2. The 3's cancel, so that leaves 1 over square root of 2. This answer is totally fine with me. Some instructors, some textbooks, or authors of the textbooks prefer it to be in a rationalized form. If you multiply both sides of the fraction by the denominator, square root of 2 over square root of 2, you get square root of 2 on top, square root of 4 on bottom, but that's 2. These two numbers have the same value. It's just this one's rationalized where it no longer has a radical in the denominator. Again, I don't get in a fuss over that. 1 over square root of 2 is totally fine with me. Cosine chi, that's adjacent over hypotenuse. Same value, cancel the 3's, 1 over square root of 2. Tangent is toa, opposite over adjacent, 3 over 3 is 1. The other three trigonometric functions are reciprocals of the three we have seen so far. They are cosecant, secant, and cotangent. If you know the first three trigonometric functions, you can flip them all over or take their reciprocal, and you've got the other three. Cosecant is 1 over sine, so if you know sine, flip it over, that's cosecant. Secant is 1 over cosine. If you know cosine, flip it upside down, and that's secant. And the same thing for cotangent. If you know tangent, flip it, and you've got cotangent. Find the exact values of the 6 trigonometric functions in the figure. We have a right triangle with legs of 6 and 8. And that should kind of feel familiar. That's the one we had on the first slide. 6 squared plus 8 squared is 100. So hypotenuse is square root of 100, or 10. This longest side of the hypotenuse is of length 10. Sine is opposite over hypotenuse. Let me go ahead and put this 10 where it's a little closer. There we go. Okay, so opposite over hypotenuse, 8 over 10, that reduces to 4/5. Cosine is adjacent over hypotenuse, 6/10 reduces to 3/5. And tangent is toa, that's opposite over adjacent, and all with respect to theta. 8/6 reduces to 4/3. To get cosecant, you flip sine over, that's 4/5 flipped is 5/4. Secant is cosine flipped over, that's 5/3 once you flip it. And then 4/3 flipped over is 3/4, and that's your cotangent value. Let's do another one with the figure we had on the previous slide as well, where we have a right triangle and the lengths of the legs are both 3. 3 squared plus 3 squared was 18. Square root of 18 reduced to 3 square root of 2. We found our sine value to be 3 over 3 square root of 2. I'm going to leave it not rationalized. Cosine was the same thing, adjacent over hypotenuse, 1 over square root of 2. And tangent was opposite over adjacent, 3 over 3 is 1. Cosecant is sine flipped over, so that's square root of 2. Same thing for secant, that's cosine flipped over, square root of 2. And then tangent, if you flip 1 over, it's still 1. Let's sketch a right triangle corresponding to the trigonometric function of the acute angle theta, and then find the exact values of the other 5 functions of theta. So we have a right triangle down here in the lower right part of your screen. We're given that the sine value is 12/13. So when you draw a right triangle, just pick one of the vertices. It could be the one up here if you like, but just pick one of the vertices, put your theta in here, and actually mark it so that you'll know what vertex everything's with respect to. Sine is opposite over hypotenuse. So where your theta is, opposite over hypotenuse needs to be 12/13. From Pythagorean theorem, 12 squared plus the unknown squared has to equal 13 squared. 12 squared plus the unknown squared equals 13 squared. X squared is equal to 169 minus 144. That's 25. So we take the square root and we get this side of length 5. And you can check to make sure they all three add up. 5 squared plus 12 squared does equal 13 squared. Once you know all three sides, then you can develop your trig ratios. We were given sine, so if we flip it over, we've got cosecant. Cosine, from wherever you mark theta, is adjacent over hypotenuse. That's 5/13. So you take the reciprocal, that's secant, 13/5. Tangent is opposite over adjacent, that's 12/5. Flip it, 5/12 is your cotangent value. I hope this video has helped. Please reach out if you have any questions or concerns. Email, phone call, ask in class if we're in a traditional setting. And just let me know if you have any questions.